In this video, you'll find the solutions to the take-home problems number 7 handout. These problems involve solving systems of equations. The primary method that we're going to use to solve systems of equations is the substitution method. So the idea is that we want to choose one of these two equations, solve it for one of the variables if it's not solved already, and then take that solution and substitute it into the other equation. That gives us a single equation with a single variable, and then we solve that equation, and then we work from there. So in this case, we actually look and see that the first equation is already solved for x. So we're going to choose the first equation, which is already solved for x. We're going to take that solution for x and substitute it in to the x in the other equation. So once we do that substitution, we get 3 times the quantity, 4y plus 10, minus 4y equals 14. So that gives us a single equation in the variable y, and now we'll solve that for y. Distribute the multiplication, we get 12y plus 30 minus 4y equals 14. Subtract 30 from both sides, 12y minus 4y is 8y, and when we subtract 30, 14 minus 30 is negative 16. Divide both sides by 8, and we get y equals negative 2. Now we're not done because the solution is a value for x and a value for y. And so now we need to take that solution that we've just found for y and substitute it back into the first equation that we had, which was x equals 4y plus 10. Now that we know that y equals negative 2, that gives us x equals 4 times negative 2 plus 10. That gives us x equals positive 2. So the solution is that x equals 2 and y equals negative 2. And that's going to be the general method that we're going to use to solve any system of equations. Pick an equation, solve it for one of the variables, take that solution, substitute it into the other equation, and then solve that. All right, now we see this in action in the context of a word problem. So we're given two equations, as we can see. So p equals 4,000 plus 30t, and p equals 5,000 plus 10t. Now what these represent, it's the same variable t, but the first p, the p in the first equation, represents the population of Alphatown. That's this p. And then the population of Betaville, that represents the p in the second equation. That's this p. But in both equations, t is the number of years since 2000. So the question is, in what year will both towns have the same population? So that means we want the two p's to equal each other. So what we get is that 4,000 plus 30t, the population of Alphatown, should be equal to 5,000 plus 10t, the population of Betaville. So that gives us an equation that we can solve. We can subtract 10t from both sides, subtract 4,000 from both sides, divide both sides by 20, and we get that t equals 50. Now again, we have to be careful that we answer the question. The question says, in what year? And the answer to the question, in what year, is not 50. Remember, t represents the number of years since 2000. So 50 here represents the year 2050. So the answer to our question is that in the year 2050, that's when the population of the two towns will be the same. Here we have a supply and demand question. So we've got two equations now. So we've got the demand for a product, and we've also got the supply for a product. In this case, P represents the price of this toaster in dollars, and D represents the number of toasters that the customers will buy, and S represents the number of toasters that the company will supply. And we want to know at what price will supply equal demand. This is called the equilibrium price. So we just want the D to equal the S. So that's the setup for our solution. We know that D equals 150 minus 1.6p, substituting that in for D. And we also know that S equals 20 plus 0.6p. Substitute that in for the S. And now we can solve. So we can, this time I'll add 1.6p to both sides. That gives me 2.2p on the right-hand side. I'm just doing that to avoid negatives. Subtract 20 from both sides. So we get 30 equals 2.2p. Divide both sides by 2.2, and we get 130 divided by 2.2. Put that in our calculator, and that gives us 59.090909. Now, P represents the price, so it makes sense to think about dollars and cents, and then we're asked to round our answer to the nearest cent. So when we do that, we get $59.09. And that's our solution. Now for these last two examples, we're going to see some special cases that will come up every once in a while when we try to solve a system of equations. Again, the general procedure is to pick an equation, solve it for one of the variables, and then take that solution and substitute that into the other equation. In this case, our first equation is solved for y, so we're going to take that solution for y and substitute it in for the y in the other equation. When we do that, we get 2 times the quantity, 3x minus 5, equals 6x minus 4. Multiply through, we get 6x minus 10 equals 6x minus 4. But now something strange happens. When we subtract 6x from both sides, we get negative 10 equals negative 4. And negative 10 doesn't equal negative 4. So we just get the variable went away, and we just get this sort of strange false mathematical equation. So since negative 10 doesn't equal negative 4, that means that this system of equations has no solution. Now, whenever this happens, you want to make sure that you didn't make an algebra mistake, because it does happen quite rarely. It happens every once in a while, but it really doesn't happen very often. So the first thing that you should do when you run into this situation is go back and check all your work very carefully and make sure that it didn't happen because you made a mistake. But if you did everything correctly, you didn't make any mistakes, and you get something like this, then what this means is that the system has no solutions. Very similar setup for this one. Again, the first equation is already solved for y for us, so we're going to substitute that into the second equation. We get 2 times the quantity 3x minus 5 equals 6x minus 10. 6x minus 10 equals 6x minus 10, and we might already tell that something strange is happening. Now when we subtract 6x from both sides, we get a true equation. We get negative 10 equals negative 10. So this means something slightly different. It doesn't mean that there are no solutions. In fact, this means that there are many solutions. And we can be slightly more specific here. What this really is telling us is that these two equations are really the same equation in disguise. And you may notice, if you go back to the top here, that the second equation is 2 times the first equation. If you multiplied both sides by 2 in the first equation, you would get the second equation. So it's really just the same equation twice. So any pair of numbers that is a solution to the first equation would also be a solution to the second equation. And so that means that any value of x and y, the solution is any pair x comma y, where y equals 3x minus 5. There's lots of different ways that we could write that, but that certainly describes what we're talking about. So it doesn't mean that everything is a solution. Certainly not every pair of x and y values would be a solution to that equation. But anything that is a solution to the first equation would be a solution to the system of equations, because it's really just the same equation written twice.